Hello students, welcome back. Previously we went through the increasing decreasing nature of the graph, and then we particularly put an emphasis on interval expression of intervals of increase and decrease. Remember, you have to answer in terms of intervals in x coordinates. Okay, the next concept is local and absolute extrema. So local maximum or local minimum, absolute maximum or absolute minimum. Extremum means either maximum or minimum, and extrema, maxima, minima, those are plural form of extremum, maximum, minimum, etc. So it goes like this. For example, if you have a graph like this, okay, let me make things up. Okay, all right. These kind of points are local maximum. So it's a maximum, but only nearby. And then among those, this one here is the absolute maximum because that's highest. Pretty clear. And then what if you want minima? These kind of things. My drawing is rather lousy, but it's really hard to see. But you know what I meant was these kind of things are local minima, and that looks like this one is the lowest, absolute lowest. So that's the absolute minimum. And the function has absolute maximum or absolute minimum at x value, x equal to c, and it is important to specify the x coordinate. If you answer both x coordinate and y coordinate, you will get credit. If you answer x coordinate only, you will get credit too. If you answer only y coordinate, not the full credit this time. A little bit of loss because the x coordinate is the important thing. Remember, in terms of intervals of increase and decrease, we were looking for the x coordinate, intervals of x coordinate, right? Similar philosophy applies here. Okay, let's go out of this drawing mode and let's come back to this notebook. Okay, here we go. And let's expand the graph a little bit further. And then, do you see local maximum, local minimum, those kind of things? Let's see, let's assume this graph just extends forever. This graph, this asymptotically extends forever. So looks like we're gonna get local maximum here, local minimum there, and that happens to be absolute minimum too. But no local maximum because, you know, this one just goes on forever. Make sense? So f attains the local maximum at x equals 3, right here where my mouse is, and the local maximum value is y equals to 3. So that part here, which I just highlighted in bold, is the really important part. And then the y coordinate part is, well, comparatively speaking, less important. If you write both, okay, that's better. But if you write either y coordinate and then if you miss the x coordinate, then you're going to lose some credit. If you write the x coordinate, which is more important, and if you do not write y coordinate, it's still full credit. Now, how about this one? Attains local minimum at x equal to -3. right here. And then local minimum value is, oh, excuse me, there is a typo. Local minimum value is -2. That's y-coordinate value. Among those, absolute minimum is right here. That happens at x equal to -3, yeah, right here. And as for absolute maximum, no, this one just goes up forever, so no absolute maximum. So absolute minimum at x equal to -3, and then no absolute maximum. Well, if you get confused, then write both x-coordinate and y-coordinate actually. If you write both x-coordinate and function value, then it's surefire way. But if I make any kind of judgment which is more important, then I have to agree that x-coordinate is more important. Now, as far as intervals of increase and decrease is concerned, x-coordinate is all about x-coordinate. Final question, determine the asymptote. Let's see, do you see the asymptote, horizontal asymptote forming here? As I move to the right, the graph is getting closer and closer and closer to the x-axis. Looks like we have a horizontal asymptote at the x-axis, y equal to 0, and not to the left, but to the right. How about this? Looks like we have a couple of local maxima right here and there, and then a local minimum right here. Good question. What is absolute maximum? Absolute minimum? What do you think? Absolute minimum here and there looks like they're the same type. So absolute maximum -1 or +1, and absolute minimum right here, x equals to 0. And right here, it looks like the graph is asymptotic. So the graph is getting closer and closer and closer to the x-axis, but it looks like it is not actually touching. So this is the absolute minimum. As for the asymptote, okay, it has horizontal asymptote, y equal to 0. Okay, so much for section 3, increasing decreasing nature of the graph.